Pig's elevator. What? Juju. Who the hell is Juju? Yep, I know that's probably some of your thoughts right now in your head. There's a lot of confusion, but don't worry. I'm gonna explain everything right now.
So it was Christmas time, and it was the first Christmas after I've gone to college. So reasonably, as someone who just turned 18 and is starting a new life, I was thinking about giving my sister a gift because she's the only family member I have in US. And so I was thinking really hard what to give her. She's got everything she wants. She doesn't want anything that's luxurious, nor I can afford it. And it was hard to give her a gift that she wanted. And all of a sudden, when I was thinking about the gift, I heard a quink sound. Yes, my sister kept a pig as her pet. His name is Juju, and why don't I just do something with Juju? So here's my idea for the gift to my sister. So this is kind of our layout of our house, and we have a Juju space here where Juju just kind of sleeps here, walk around sometimes. He's free space. And here's a living room, and here's a like a hallway kind of thing. And these are stairs, by the way. And then there's a patio over there. So Juju has a morning routine every single morning. Okay, so he would come up those stairs and hit the patio first, and he would just get his breakfast in, and he would get a little vitamin D sunshine, whatever, a little session in. He would just lay here and get his tan. And after that, he would come back and walk around the living room. But here's the issue: whenever he wants to go back and sleep, he can't because there's one thing that Juju cannot do is going downstairs. So every time when he want to go down, we have to carry him down the stairs. It's very annoying, and here's a proof of that. Juju is not light, and he all when we are carrying him, he's also not very he kicks me a lot of times. So I came up with the idea: Juju's elevator. So whenever Juju's finishing his routine, he just hit the elevator and go back to his space and sleep. We don't have to do anything, and it's hands free.
So this is my first ever DIY project, and so along the way, I'm still kind of figuring things out. And before I start, though, I kind of generalized the whole process into three different phases. So the first phase is completing the idea, right? So you have to think about how the outside of this elevator is going to look like, and then what parts you need. Like you have to list the material you need, and then you have to design things. You have to design the circuit and code, right? So these are the designing phase, and you have the second phase where your idea is more complete. Now you have to get your hands on it to build it, and after you're building it, of course, in the middle of the building, you will realize a lot of realization where there's some limit to your design. There's always some limit to your design. And then you have the final phase where you modify and testing and improving your design, right? So let's talk about the first phase right for now. So first phase, I've actually separated into three different sections. So the first section is, of course, how the elevator is going to look like. And I'm going to do that through CAD. I have a complete CAD design that has the first complete idea of how this elevator is roughly going to look like. And then you have coding, is where you define, okay, what kind of motor do I need? What kind of sensor do I need? I'm kind of thinking about the situations where this elevator is going to use. And then you have the third phase, the third section, which is the circuit design. After you get every material, right, you want to connect them. So that's the circuit. So here's my CAD design.
So this is my cat for the elevator, and as you can see, it's pretty solid. Pretty solid. Okay. So there's different components to this cat, and so there's the contacting plate, what I call contacting plate. So this part here, contacting board here, and there's a plate below him, and there's a base. This is what I call base, and there's also fence. This is fence. This is what I keep Juju from jumping off. And there's also, of course, the pools over here, right? Okay, so let's talk more deeply about each. So the contacting plate. So as you can see, I hide the top plate because the top plate is where Juju is going to be standing on, but below that there is 4 different way module here, and these are just to test what's on top of the contacting plate and to see the weight change of that plate, because as soon as Juju step on it, then if the plate doesn't move, then this weight module is gonna sense more weight, right? Because it's stuff on it. Yeah. And so this is the idea. And what's pretty interesting is here, where I have pulleys against this trail, this pool, and it's acting like it's rolling on trail. So it doesn't, theoretically it won't rotate, right? It won't tilt. We can keep the platform moving up and down like really leveled, uh, theoretically. And here I have a hinge, and what this is gonna do is that this is gonna be attached to a string that's gonna cross the top here, and it's gonna go through the pool. So wait, sorry, hinge here, go across the pulley, and go into the pool, and right below that there is a pulley again to just make sure the string is in its position, and attached to this a little motor where it's gonna spin and gonna pull the string up or whatever. So that's pretty much it for the contacting plate. And let's talk about the base. So here I have already cut off some space for the electrical part, where I put my circuit. And so here those two tunnel, if you may call it, is for the power supply, which I'm gonna put right here, because this side is closer to the to a plug. Uh, and yep, so power supply wire goes through here, and then to the two driver panel here, and then Arduino, and then the way module is all here, and here's the motor. Motor is gonna be here, and there's obviously wire gonna go through that too. Motor here going through that too, and that's pretty much it.
So that was my cat. And let's talk about my code right now. So I know a lot of you guys think coding is so hard, so complex, but at least for this project, code is relatively easy. And I'm gonna explain it in a very detailed and well-structured way so that everyone watching this video will understand. But if you really hate coding that much, you can just skip along to the circuit part. But for those of you who are interested in coding, or at least trying to be interested in coding, here's my code.
So here's my code for the elevator, and I'm gonna briefly explain how my code works. So I'm using the Arduino IDE, and this is very similar to C++. So if you're familiar with C++, this is very easy to read for you. If you're not, it's fine. I'm just gonna briefly explain how my code works. And let's start from the beginning, where this is the global scope. What's called global scope is just defining a lot of variables. And if you can look at this, these are the pin definition, where these are me defining which pin I'm using on the motherboard, and these are just the numbers, right? And then here's here's a variable that I've used very often here, total weight. This is to record what's on top of the contacting plate, so we can know if the pig is on it or if there's a weight change. Here's something coming from the library that I inputted here for the weight module. This is specifically for the weight module, and you can download the library like right here. You see the library manager. You can just install from here. And these two lines are just essentially telling the computer or the Arduino that, oh, these 4 pins are from this specific weight module, and it tells it to read in a certain way. Okay, so here is some debouncing variable. If you want to know how debouncing works, here's how it works. But if you don't want to know about it, then you can just skip along. Okay, so let's explain debouncing real quick. Why do we need debouncing switch, or what are we actually doing? So let's just say here, this is a switch, okay? So how a switch normally works is that so you usually have some sort of stuff here, and it's gonna be a button, and you push down, right? So push this wire to connect, okay? So after you connect, this wire has, let's say 5 volt here, 5 volt here, and 5 volt here, 0 volt here. Once you connect it, then this whole line becomes 5 volt. So the other side reads the information. Oh, from 0 to 5 volt. So this is being connected. So this is being pushed. That's the ideal case. Okay. But realistically, most of the time, instead of just being pushed down and connect and once for all, usually what a switch works, how a switch works is that it doesn't usually just go down and stuck there. Usually there's a little a harmonic motion or whatever. It doesn't stay there. It goes up again and goes down and goes up again and goes down. It goes up again and it goes down. And this all happened probably like 1,000 times in a millisecond. So it happened really fast. And you don't want to confuse the computer what is going on, or you don't want to hurt the motor because the motor kind of depends on the switch. Have to react to the switch, and then you don't want to hurt the motor from turning on, turning off, turning on, turning off, turning off. So we want to debounce it. And I have a debouncing code later on in the code that I will talk about it later. So here's another variable that's very important that I use a lot later on in the code. I just put it here. Bottom state, top state, which just tells me whether the play is on the top or the play is touching the bottom. And so here's a setup code. This code only runs once the motherboard is the Arduino is being powered. This only run once. So here the first line here is starts like it's acting like it started a stopwatch. Okay, it's counting time. And then here 4 lines are telling the computer to communicate with the wait module, and it tells it to initialize. And these pins are to define whether those pins above that I defined it above, whether they are output or input pins. So for all the motor pins, they are outputs, right? We want to tell the motor what to do. But here, the bottom trigger and top trigger, these are the two switch I have on the bottom and top. These are obviously going to be input because we want to know, it's giving us information. We want to know if the player is on the bottom or on the top. So the pull-up method, you can see here, instead of just input, I have input pull-up. So this is a little more unique. Again, if you want to listen, continue watching. If you don't, here's the time you should skip to. So, okay, what's a pull-up method? What does that mean? So normally we have a switch like this, like last time I showed, and it's going down 5 volt here, 0 volt here, and this just connects. But on the pull-up method, you can achieve this through breadboard, but like a circuit. But I'm gonna just show if as a switch that has an internal mechanism of a pull-up. Okay, so what a pull-up method is that there's 2 lines here, so it's just 1 line and with 5 volt here. So instead of this line being 5 volt, this line is 5 volt now, and this line is 0 volt. And what this switch does is that once there's something up here, push this wire down, it connects to 0 volt. So this whole line becomes 0 volt, from 5 volt to 0 volt. And why is this method better, or why do I prefer this? Is because, first of all, the original method, right, when you just have 1 line here, it's from 0 volt to 5 volt. So we are reading a number. Right? As long as it's not 0, just potential voltage, it can be connected, right? So that's very easy to change because due to the environment, there's this random electric field or whatever that can pierce through those wires. So there might be a lot of random voltage just due to the environment of the switch. Why pull-up method is good is that it stays at 5. If it's not pushed, it stays at 5. Only once it's pushed, then you read 0, which is very hard to read. Okay, a 0 is harder to read than a small change, right? So this is better because you just have less effect by the environment, and it reads a better number as a 0 than just reading some random voltage. Okay. Again, here is a variable that I defined that I'm gonna use later on, and the motion state is basically telling me whether the play is on its way down or on its way going up. So here's my main code, and how I coded it is that I put it into different cases, scenarios, and tell the motor what we should do. Okay, so of course in the beginning of the code, you should probably update your load cell, which is your weight module, to get the newest information on top for the weight change, right? And this total weight is just the sum of the two weight that you get from two different weight two different weight modules. Here's the whole debouncing process. I've already talked about that beforehand. Of course, if you want to look at more YouTube videos on how this works, you can do so. But I'm not gonna waste time explaining this here. But it is here. You can use whatever I have here. So here's a bunch of different scenarios for my code, and in general, there's four variables that I would use to define a situation. First is the total weight, is whether there's to read whether Juju's on top of the contact tape plate or not. Here's bottom state and top weight, which is the two different triggers or switch on the bottom and on the top of my elevator to know whether the plate is on the bottom or on top. And the motion state. This is to define whether the plate is on its way down or on its way up. And so, okay, so for the first scenario here, we have this plate is on the elevator, but when the plate is on top, so you have total weight of about 100, meaning there's something on it, and bottom state 0, bottom state 1, and top state 0, which we talked about before. If you have 0, then it's getting activated. So Juju's on the contact plate waiting to go down, so you want to start the motor. And digital write direction high, so high, we are defining high as going down, and then the log write motor 1 255, that's telling the motor to go on to run at this power, and we're defining motion state as 0 because we're just defining 0 as the weight going down. Okay, so 0 means the plate is going down. So here, lower here, the only change is that top state become 1, which means if it's not on top no more, and motion state doesn't change, and pig is still on it, that means the pig is on its way down, so you want to keep running the motor. So you have digital write, same direction, but you want the motor to keep running, right? So here's a situation, interesting situation, where motion state is actually 1, but Juju's on it, my pig is on it, it's still in the middle of neither on top nor bottom. So this is a situation where the pig is on the elevator, but the plate is going on its way up. So when will that happen? It will probably happen when Juju has got off the elevator, and right when the plate from the bottom is going up, Juju hop back onto the elevator. So of course at that point we want to stop the elevator, right? We don't want Juju to get caught. So here's a two line we stop. We're telling the motor to run at 0, which is just stopping it. And here's a delay. So instead of changing direction immediately to on its way down and powering it, we need a little delay. Why is that? It's because we want to do a little motor protection here. So we don't want to just immediately stop the motor and immediately power it on the opposite direction, because it can be very destructive to our gears. So we want to add a little delay here, and of course change the motion state to on its way down. So here's another situation where pig is on the elevator when it's on the bottom, so we just patiently wait for the pig to get off. So we have our plate at 0, just don't power your motor at all, just wait for the pig to get off. Here's another situation where Juju just got off and the plate is at the bottom. You want to reverse your way, right? It's low and it's high, right? So low is the opposite way, so it's going back up, and you power your motor. And of course, don't forget to change your motion state as 1, because 1 means goes up, right? 0 means goes down. So here's another situation where, again, bottom state is 1, top state is 1, motion state was 1, meaning that the plate is in the middle, you're just not on it, total weight is less than 100, and it's on its way up, so you just keep going up, right? So here's another situation where Juju's not on the elevator, plate is in the middle, but it's on its way down. So when will that happen? It usually can happen when the plate is almost getting on the bottom, but Juju jump off because it's very close to the ground. So at that point, because Juju is already off the elevator, we just want to bring the plate back up. So again, you want to stop that, like we did here before. You want to stop the elevator first, and then delay for a little bit for motor protection, and then you opposite way, right? And also don't forget to change the motion state 1. Here's another situation where the total weight is less than 100, bottom state is 1, top state is 0. So the contacting plate is on top with no Juju on it. So you just want to wait for Juju to get on for the next transportation, and just set the motor to 0. That's pretty much it for my code, and yep. Okay, so now I'm gonna explain my circuit a little bit. This is if you look at this at the first sight, it's very messy, but after my explanation, I'm sure it'll be a lot more manageable. So, first up, we have a power supply here. Okay, so the power supply just only supplies to the motor driver, because they are the only thing in the whole circuit that can take the high voltage, take the high voltage raw voltage from the power supply, because the power supply is supplying around like I think 200 watts, and the motor driver basically converts that power and put it back to our motor. And also they also both has a 5-volt output to run our Arduino. So here's a breadboard. This is the line for 5 volt, and this is the line for ground. Every single ground pin right here. So for the 5 volts, so these two motor drivers power the 5-volt ones, and the Arduino also needs a 5 volt, and so does the two-way module right here. So both of them are connected to this, and both of their ground pins are also connected to this. And let's talk more about the motor driver. The motor driver has two input pins, PWM and DIR. So what PWM is that it's a pin that lets Arduino to communicate to the motor driver how much power do we want the motor to run. So it's an analog, right? It's a value. It's not just on and off. It's a value. And DIR is just what direction we want the motor to run in. So that's it for the motor, and also there's a ground pin for the a ground wire for the motor, and the voltage wire for the motor. And that's pretty much it for the motor driver. And let's look at Arduino. So those two blue lines are from top and bottom switch, and they are basically only one of them is connected to the Arduino to just it's switching between 5 volts and 0 volt to just whatever. And here's the two ground pin connecting to the breadboard. The yellow wires and the orange wires are all from the way module. So the yellow ones are DOUT wires, and they are basically telling the Arduino how what's the weight. Okay, just telling the information, pure information of what's the weight, and this orange wire is a little more interesting. It's a SCK wire. So it's a wire where the Arduino tells the weight panel or the weight module to read. It tells it to trigger to read. So that this pin is very important, as important as the one that reads the information. So here's on the left side here, if you can see my cursor, this part is how to wire HX711, and I'm sure not everyone is interested about it, but if you are, this is how you wire them. And this is pretty much it. And now look at it, and it is a lot more. I'm sure it's a lot more manageable than you just first look at it. And that's it.
So that was pretty detailed explanation of my designing phase. And after that, now it's a building phase. Now, I'm gonna show a couple clips of me building, but essentially I met a couple critical limitation of my design that I'm gonna explain later after I show the clips. But here's the clips. Alright guys, it was New Year's Eve yesterday, and I didn't go. I was staying at home working on my project, so I didn't go to the strip to see the fireworks. And I was thinking of the fireworks, and I was like, let's do some makeup fireworks. And there we go. Okay, so this is so far what I have for the finished, I guess, the contact board. And so we got four module like right here. It's not taped yet because I'm gonna tape into the upper board, and once I taped it, you can't really see the inside. Cable managing and some welding into the pin, because I don't really want to do the female male pin method, because this is gonna be moving a lot, and I'm scared that it's gonna take off. That's why I'll just solder it onto the board. And okay, this is the frame I've been building today, and I only did this. It took me like literally 2 hours to make this because I'm cutting like this piece as you can see, and I'm using like hand saw, so it's really painful. But I did this pretty good. It doesn't look pretty because somehow it's a little chopped, not straight. But as you can see, it can support itself pretty well. Like it doesn't wiggle at all.
So this is a picture of me trying to cut the base for the project, and you can see I have the cat open up on the right, trying to see what's the measurement and stuff. But it was pretty fun. It was pretty fun. So this is the actual my actual circuit. And here you can see it's the Arduino, the two black motherboards. These are the motor drivers. And yeah, and here's the motor and the wave module on top of it. So the wave module actually, when at the end, was changed to the base. And yep. So that was a lot of clips of me building, and let's talk about the limitation right now. So there's the first big limitation I met was when I was dealing with the weight sensor. So the weight sensor didn't really work. The original plan was to put a weight sensor in between the two contacting plate and kind of like sandwich it and just put it in the middle. And that didn't really work out because the weight sensor turns out to it sends a really weak and small voltage to the HX711, which is the controller panel. But that process very easily altered or affected by the environment. And also I'm connecting them in a very long wire, which means there's a lot of noise along the wires. And the longer wire you have, the more noise you can experience in the middle of them. So the readings was very just inconsistent and things. And so I came up with a solution to put the weight module at the bottom. So theoretically it works the same because in regard of physics, once Juju step on the elevator, the weight of the elevator as a whole increase. So if you put the weight sensor at the bottom of the elevator, it theoretically still works the same. The only downside of that is that the elevator is very heavy, and Juju could be in proportionally smaller than the weight of the elevator, which might make the reading a little harder to read, but we'll see. So another limitation is that the pulleys. So the original plan was that the pulley is going to shape like a diamond kind of shape around the aluminum bar, and turns out that I can actually, first of all, it's very hard to cut. That diamond shape is so hard to cut, and for some reason I can't get the pulley onto the contacting board. So I changed the shape of it. I changed it into a square shape, which theoretically still works the same. You just have the pulleys go against the side of the aluminum bar instead of the corner, and it still works the same. Yeah, that's the only big limitation I have. The rest of them was just small changes, which doesn't affect much. And let's see the result. I don't know. Yep, I failed miserably. And yep, I'm also very disappointed at this, as you are, I'm sure. But there's a couple reasons why I failed. So the main cause of the failure was because one of the non-motor side of the contacting board got caught, so the whole thing got tilted. So that's why I wasn't going up. But the motor didn't know this, so it just kept going up. So eventually, the string that was attached to the contacting board just broke, and that's why you can see in the video there's something flying off. It was the string just snapped, and then the pulley on top just flies out too. And there's a couple ways that I can fix this. I mean, the most easy way is to, instead of two motor, I just put four motors on each corner so that there won't be a non-motor side and there won't be anywhere you will get caught and then just won't move, right? If you have just four, you can just go up simultaneously. And but unfortunately, right now, I mean, you know, I'm away in American University, which is in DC, and this project is in Vegas, so it's hard for me to just go back and forth. I mean, I've already done that multiple times, so it's kind of hard for me to keep doing that, especially the finals coming up and everything. And so unfortunately, I won't be working on this project for a long time. But you know, I still have summer.
like hopefully I can get my hands back onto that project again. Um, but I mean, during the whole process, I still learned a lot. I mean, I relearned CAD. I relearned Arduino, the language for Arduino within a day. I designed my own circuit. Actually, I learned a lot more about like electrical stuff than I expected. And it was a fun process, I would say. Um, I mean, having yourself building your idea and making your idea into the real world is something that's always exciting, and just simply building stuff is very fun. And yeah, that's pretty much it for the video. I know the result isn't really pleasing or is very upsetting, but we'll see what I can do in the summer. And good night, y'all.